Hi guys, welcome to a new lesson for the Embergen Introduction course. Today it's time to start playing with a real world scene. So my main purpose today is to create a cloud, a static cloud. In the past we talked about some nodes like the shaping, the emission and stuff like that. But today it is time to create something from scratch, something that can be used in production. So it is time to do something more interesting. So, in the past we talked about the primitive, and today we are going to use a standard primitive. So we are not going to focus on the cloud shaping. So we'll do everything that is needed to create it with the simulation. We can use a lower scale bounce. So let's use this bounce, but we'll have no smoke moving up, rising up, because we are talking about cloud. So we can scale the bounce. I'm not going to create a real world scaling cloud, but we can take care about something that can works in the viewport. So you see we have just a little bit less space over the z-axis because as I said we don't need to have the fluid rising up. So actually it is cut, but that's normal because actually we have the temperature, so we have the buoyancy. So the primitive actually is a torus. But we are going to create something more complex in the next lesson. So today we will take care just about the emission, simulation and volume rendering in viewport. So let's start creating something interesting. We don't need the fuel rate because we don't need to burn anything. We have just a cloud, so we are talking just about a simple gas. Let's go to have an higher smoke rate, because in this way we'll have an higher density, and it will be helpful because we are going to take care about the density in a really complex way later. No temperature, so you see that we have no more buoyancy, we have just turbulence, so we have just the smoke moving with the dynamic inside the volume, but it is no more rising up because we have no temperature. Let's continue to check what we can do over the emission. We don't need to control the pressure because we have nothing so complex about the pressure because we have no explosion and stuff like that. Let's see, we have here the particle emissions, so maybe we can take care about also the emission animation. So we can decide when the cloud is emitted, because we are going to create a static cloud. So we'll emit the cloud, we'll see the evolution, and then we stop the simulation. That's the idea. So you see that we have the cloud evolution, and then we go to decide, for example, that we love a specific frame and we are going to use it as final. So let's go back, let's see again. You see, for example, it is going still to expand and to have the smoke disappearing. So obviously we don't need to use so much frames. It is something different. In a coming lesson we're going to see how we can create dynamic clouds, so it will be different. Okay, let's go to animate the emitter activity. With the right mouse button we can create keys over the dot sheet. So it is on at the beginning and then it is off around frame 10. So you see we have the emission, and then we have expansion, and then we have the density falling down. That's normal. We are going to have something more complex in a few because we are going to take care about the density and the other stuff. So it is time maybe to start playing with a simulation. So we need to to see how the solver is going to take care about the simulation. We need maybe also an higher resolution. We are going step by step to have a bigger space, and maybe then we focus on the space needed to have our final cloud. So for the moment we can apply this resolution. You see that we have a little bit more space, and we go lower with the voxel size, so we'll have an higher resolution, more quality, and more complex behavior in the dynamic. So I like just to make a different scale to have the right space to obtain our final result. We have to take care about also the memory for the GPU. It is big enough. We have to take care about the scaling for sure, because we need a bigger cloud so we can scale the radius of the torus. So let's say that we like to see the emitter and back to the first frame, and then we go to scale it. Okay, so it is bigger than before, still out of scale, but it is nice enough to make a nice simulation. Okay, so it is going better than before. We have still too much details, strange, you know, puffy, turbulence, so we have to take care about it. By the way, first step is to save it. Let's call it cloud free, because it is the free version of this tutorial. So back in the simulation, let's move step by step. We don't need to work on the particle physics. We have to take care about the simulation. We have here advection accuracy is something related to the dynamic movement and the velocity and stuff like that. So we have first order, second order, fourth order. The fourth order is the more complex one, so it's the most complex one. So we have a higher quality behavior, but we have obviously a little bit slower simulation. By the way, it's going to be really nice to use it to have a really high quality simulation. So next step, let's see here, we have the time control. We don't need the time control because we have no looping. We have not to control anything. Maybe we can take care about the force noise. The force noise, we are going to use some forces to shape the basic cloud shape. So we are going to use two forces. The first one can be called, for example, noise large. So we know that this one is the one that is going to create a larger details. Higher scale, higher level of octane to have more details over the distortion, and that's all. Okay, so you see that we have large scale distortion, and that's nice because it is moving to be more similar to a cloud, and it was just done using the noise. Really nice and effective. So let's go to control this one, the force activity, so it will be animated. We are going to use it just to shape at the beginning the cloud. So it is on at the beginning, and then it's off around maybe frame 25 or something like that. So we'll have less distortion because, you know, we are not more emitting also fluids after a while, but you know, it's better to have more keys because we can decide, for example, to have more frames for the emitter activity, so we can take care about it later. Let's get to have another force. The second force will be with a small scale, and it's going to have details to a lower scaling, and it is still useful to shape the cloud. So we are going to use both. This one can be scaled lower, and then let's go to have a different amplitude, maybe let's go to change the octave to have a higher level of detail, and no animation. This one is not animated, it's just a noise to create disturbance. So obviously the step we are going to create is not the only one. It is not the only way to do it. You can just use this way to create something nice. Let's go to animate also the amplitude. So at the beginning is higher, let's say 30, and then it will goes down. Again, we have more frames of turbulence with the forces, and you know, we have the emission that is over before, but don't worry about it. So let's go to have a lower scale, because I don't want to have so big, large scale detail. Okay, something like that can be a good start point. Okay, later we can take care about it and change something if needed. So let's continue in the simulation. We talked about the adventure accuracy. We don't need to control the tank control. So let's go in the combustion panel. We have no combustion actually, because we have no fueling, so we have no flames, we have no explosion. So we can move a step forward and we can start talking about the dissipation. So we can control how the fluid will dissipate. Some information are available because we have the smoke, some other are not available, so we have no fueling and no flames, so we don't need it. So we don't need dissipation for the temperature. We can set to 0 and everything will stay as before, because we have no temperature, no burning, and nothing like that. We get to have a little bit of more dissipation about the velocity. So that's something I like to have. So we are going to dissipate the velocity step by step, and then we go to control. So maybe the smoke dissipation. So let's have a little bit less dissipation. So we'll have a slower dissipation about the smoke, so we'll be able to have higher details all over and more dynamic rolling about the cloud. Then dissipation is done, we can control the vorticity. Vorticity is based on something related to the smoke dynamic, the fluid dynamic. So it's based not on an external force, but it's based on the fluid behavior. Okay, so we have two layers. We have vorticity and we have large vorticity. We are going to control both because I like to have a more deeper control, so bigger intensity for the vorticity. So we are going to have more vortex, more rolling, and it will give us something more interesting. So that's something useful to create a similar shaping for cloud. And then about the large vorticity, let's go with 45. You see that it is moving to be more similar to a cloud. By the way, remember that this is just an example of how we can create a setup to control the cloud. You see that we have a lot of details. Maybe we are losing a little bit in quality, but we'll take care about it in a few with the other parameters and values. So don't worry about it. So we are going to have an higher resolution. We are going to break, as you see, the the cloud surface, so it will be less smooth and we'll have more turbulence, more perturbance, and it is a really nice way. Actually, the vorticity is based on masking, so there are values and parameters that are controlling how the vorticity is applied. We have 100% based on velocity, and we are going to take care about it, but I like to add something else. So I like to decide that there are other values and other parameters that are controlling the vorticity. So in this case, actually, you see there we have the temperature too, for example, but we have no temperature, and we like to work on the density, so the smoke. So where we have a higher density, we'll have a higher vorticity. So let's go for 50%, and maybe we can have, obviously the density is really similar or similar all over, so it is maybe less visible as effects because we have to take control also about the density, but it is something. It is the base to create something more complex. We can maybe create a compromise between velocity, so I like to animate the velocity, so we are saying that the velocity is controlling the vorticity more at the beginning and less later. Okay, so we have two keys, one at the beginning, one around frame 25. So at the beginning it's creating more vorticity, and then it is going lower and we'll have more masking based on the density. So vorticity is done. Later we'll have also the turbulence, so it's another layer of variation for the density and the how it works. We have the forces. Actually, we have the buoyancy there, but we have no buoyancy because we have no temperature. So the buoyancy is the force that gives us the possibility to rise up the smoke, and in this case we have no buoyancy, so we can essentially set to 0. It is not important. Smoke weight is nice because we can give a weight to the smoke, and in this way we are saying that the smoke can fall down faster. Okay, so it is nice also when you are creating explosion and stuff like that. By the way, it is good to make rolling maybe a little bit lower, and it will be useful also when you have the buoyancy. So let's have it, because another thing that can be useful is to have also a little bit of temperature, to have an evolution based on a more complex behavior. By the way, today it's just the beginning for cloud simulation, so we can stay with a simpler setup. So forces are done. Something that can be useful is the wind. We like to have a wind energy, and we have some parameters for the wind. Actually, we have the direction, we have random direction, we have the speed, and we have a random speed. So actually we have the wind set to the y positive axis. I like to move it to the left, so we need -1, so it is negative x axis, and then we go positive obviously is over on the right and negative is on the left. We go to set to 0 over the y, so we have just the wind to the left. We have a little bit of randomization over both axes, so it's useful. And then the speed. If we use a really high speed, we are talking about half meters by seconds. You see that we have the cloud rolling and moving really fast to the left. It's something that can be useful when we are going to simulate dynamic clouds, but I prefer to have a low level because I like just to shape a little bit the cloud based on the wind. So let's go to 0.04. We are talking about 4 centimeters by seconds. So it's slower. Maybe we see a little bit of evolution, but it's really, really slow. Okay. We can randomize the wind energy using the wind cows, and it is something that is useful because more cows, it's more natural. We go for 0.02. 0.02 means that it's minus 0.02 plus 0.02. So the final speed for the wind will be between 0.02 and 0.06. Okay. So wind is done. Shredding is nice, but we don't need it for the moment. We can play with turbulence. Turbulence use a turbulence, so a distortion, but this distortion will make the density falls down. So we are going to use in this case the smoke turbulence, and we're going to use the scale to decide where it is available and where it is not available. So let's go to have an higher quality to be sure that we are able to see the right level of detail. So let's go for 0.03 for the voxel sides and set back the scaling for the bounce, but we'll take care about also the bounce scaling later. Okay, so apply. We are using a lot of memory for my GPU, so let's see if it is fast enough, slower than before, but it is still working perfectly. You see that we have a lot of detail over the surface, so that's really nice. So we can move forward. You see that we have a lot of turbulence, we have the shaping. If you like, you can have an higher energy for the noise large to have a different shaping. By the way, let's go back to the turbulence. Okay, so let's go to have an higher turbulence, 100%. And in this way, with this turbulence, we are changing the density accordingly to the noise sides. Okay, let's see what's going on. You will see that it's falls down the density. It will be generally applied all over because we have a really small scale for the turbulence. Turbulence side is set to 1. So you see that everything is losing density. It is a nice effect, but I like to apply everything all over with a bigger scale. So we'll have some areas with this kind of turbulence density, and other areas with higher density and a really nice variation. So turbulence sides, let's change from 1. Animation speed can stay maybe slower to 1, and turbulence sides will be really big, so 50 times bigger. You will see just some areas with a turbulent density falling. So you see there, for example, here we have a higher density, and we have other bigger area that are losing the density, and that's really nice because with a simple emitter we are creating some complex cloud. Maybe 100 is too much. Let's go to 25 because I like to have a slower simulation for the smoke turbulence, but maybe 25 is too slow because it's not so visible, and I don't want to simulate too much frames to have the cloud. So let's try with 50, and we should see the areas as before. Okay, you see that something is changing here and here too, and other areas have a higher density. That's really nice. Nice. Okay, let's move forward. So we have the turbulence that is working perfectly, so we can maybe talk about the diffusion. So the diffusion is the expansion of voxel data to the voxel around, and in this way we'll have obviously we can lose density because we are extending the value and diffuse the value of each voxel to the voxel near the voxel we are working on. So it is nice because it gives a nice effects. So let's try with 50. We'll have a really high density losing process. You see that we have less details. Generally, the look is much better than before because it seems more cloudy, but I think that's too high. So we have too diffusion, so we are losing too fast details over the surface. Okay, so it depends on the stuff you are trying to achieve, but I like to have a higher level of detail over the cloud, so it's better to have a lower value or maybe animate it. So we'll have more diffusion at the beginning and then less diffusion. It will be maybe the best compromise between the different value. So we can animate, and let's go to create some keys. We'll have a key for an eye diffusion of 35 until frame around 50, and then maybe we'll have something lower. Sorry, I have to, let's double check. Okay, that's my fault. Okay, and let's go here for maybe 0. So we have eye diffusion at the beginning, and then it is going lower and lower. Generally, the look is really nice because it is puffy but well detailed. Okay, you see, that's really, really nice. We are losing not so much details over the frames, so we have a lot of frames, maybe around 100 frames to decide which is the cloud we like to pick to be exported. Maybe we can have this key before, so it falls before we thought. So diffusion is done, vorticity is done, forces are done, so we have to see if we have to do something else there, but I think we can move to the general look about the rendering. So it is something we are going to play just to be able to render and visualize something really nice in the viewport here in Embergen. But you know, when you are going to export, it will be based mainly on the 3D software you're using. So here we have the scene. Essentially, the scene is the volume is the shading of the volume, is how the volume is treated and used in shading. Okay, so let's go to work a little bit on it. So let's stop. Okay, that's the volume shader. It is based on the ray tracer we have here in Embergen, obviously. So again, please understand that what we are doing now is just for rendering in Embergen. A little bit high intensity for the light, trying to simulate the sun. And then we can play with the volume shader. So here we can decide the general look, how it is interacting with the lights, the color, the shadows and stuff like that. So we are going to take care about the lighting. We are going to take care about the color in general and how the ambient is working together. But before we can set to a higher quality the rendering and viewport. So with the setting from the viewport, you can essentially for the moment use the quality viewport. It's something like a multiplier. Using the value, it will adjust all the other parameters automatically. Okay, let's say 4 maybe. It is really similar to 5 in this case. Visualization will be a little bit slower than before, but the quality will be higher, so it's nice enough. Back to the volume. We have to take care mainly at the beginning, mainly on the light. So we have, for example, shadow softness is some parameters will be not so visible in this case. So we are just going to take care about what's going on when we see in the viewport. So you see if we have not so high variation we don't need it, okay? So then you see that we have the shadows divided between the mid, the short, and the long range. So here we can do something to achieve a more cloudy look. And then the AO, the ambient occlusion, is not so useful in this case, but it's useful, the ambient shadowing. So it is something related to the ambient coloring, something like, let's say, a skylight, but in a really, really simple way. So we are not talking about the global illumination. It is just something related to the coloring from the ambient. So I'm going to use some values I picked before because it is a setup that works really nicely. So actually it's something like a brown color. We go to a more sky color. So let's go for a gray moving versus you know, something like a gray with a little bit of blue tinting. Then we have the possibility to control more stuff related to the scattering, and the eccentricity works, you know, to decide if we have forward scattering or back scattering and stuff like that. So we can take care about the value that give us a more cloudy look, and this one is really not bad. It is going to control how the lighting is scattering inside the volume and where we see more scattering, if we have more scattering on the back or on the front. Smoke scattering and stuff like that, we see nothing because we have no fueling, we have no flames and stuff like that. So we have not so much possibility to control in this setup the smoke scattering. So it's enough about what we can achieve. If you have colliders, you can decide how the colliders will behave for occlusion and shadows, but we have no colliders in this setup, so we have to take care just about the volume. So we are moving near to the stuff I like to simulate, but we can take care about something else maybe. Here we have the properties for the render, so you see we have, for example, the fire color intensity, but here we have no fire. Then we have the color for the dense smoke and the thin smoke. So here it is something we are going to take care. And again, we are going to use some values I used before on a previous test. So it will give us the possibility to have something more similar to a cloud. That's for the dense. And we do the same for the thin. So we'll have a more white color. So let's go to change it. Okay, you see that it's really visible what's going on. Okay. And it is a really cloudy look. Really nice, I think. Again, please remember that if you are going to export this one as a VDB, you will have no changes with this parameter, because you see the export VDB is before the volume. So it's just for the rendering there. And then we can take care about some parameters for the scaling there. You see that we have, for example, the smoke density, we have the limit, so we can control which is the minimum density we are taking care about in rendering. And that's really nice because it is giving us a really wispy clouds, and we can use it because it's really nice. And then we have, for example, the limits, so we are saying which is the limits we like to pick. So we can have everything in the volume, or we can say the minimum amount is higher, so we have this kind of really high wispy clouds. So I think that's really realistic, you know. And again, we are talking about a torus, so it's amazing what we are able to achieve with our really basic primitive as emitter. Then, if you like, we have here also some parameters related to the smoke clamping density, the smoke density multiplier. So We can do a lot of things, but I mean, if we see this viewport, I mean, it is really, really nice, and the quality is still not the maximum. I think you can play, we have something like that also in the other software, so we can use it. For example, we have the possibility in other software to decide which is the minimum density we like to use. So we can achieve something like that also in the other software. This is the smoke density multiplier, so you can change how much density we have. So you see we have more deeply control over the density and the final look for our cloud. I like to have the default value, 95, is nice enough. We have a nice level of detail, we have wispy clouds, we have high density with shadows, gray shadows, so I mean, it is perfect for me. And then we have some post-processing. For example, here we have the Sharpen. The Sharpen is able to give us the possibility to control the sharpness and the volume. So it's something we can do, and it's again a post-process effect. So you see we are going to have higher details or lower details, just adding a post-process over the volume. So it is something that is going not to change the simulation, but again, it's just a simulation in rendering, okay? It is something you can do with the shading in other software and other 3D rendering engine. Other things, we have more effects there about the modulation for the post-process. We have a lot of stuff that we can do, and maybe we'll take care about it when we are going to work on explosion, fire, and stuff like that. We have also the slicing, so there are many things that can be done over the volume, but in this case we have, I mean, we have a nice setup. So we'll talk about it. You see that we have the possibility to modulate a lot of properties about the volume. So all the data we are creating in the volume are moved to the rendering, so we can take care about also the rendering setup. That is something again related to the real-time ray tracer. So that's the rendering setup. We have the tone mapping, so we can control something about the coloring. You see the exposure, the gamma, the color vibrance. So we have some stuff that can be changed here. We can play a little bit with color vibrance to give a better coloring. So sorry, let's go back to 1 for the exposure. And then you see here we can play a little bit with the color vibrance. And then we have the contrast, we have the brightness, we have the dyed ring, for example. We have many ways to control the final look. Something simple but effective to have a better quality for the rendering, or something more cinematic and stuff like that, guys. So here we have some control over the colors and the scene, so we can decide, for example, how the sky works, how the terrain works. So you see we have, for example, sky set to atmosphere, we have ground set to checkerboard, so we have the possibility to manipulate the environment, but actually we are just focusing on the cloud, so we don't need to take care about it. It's not so important. We have many other parameters about the rendering, but we'll take care about it in the future. So you see that's the simulation we have at the moment. Really nice, and we have a lot of frames we can use to create the final cloud. So that's, I think, amazing, but we can have a better quality playing with a simulation bound. So you see that the cloud is smaller than the bound, so over the y-axis is okay, over the x-axis we have too much voxel used that are not useful for the cloud. So let's go lower on both axes. So you see we have less space, but we are using less memory, so we can speed up the simulation because we are making a simpler simulation for our GPU. If you have more GPU memory, obviously it's less complex, but again, it is not useful to have voxels that are not used. Okay, you see that we have now 5 gigabytes of memory used, and that's really better. So we can move the cloud down, and that's really faster than before to render and to simulate. Okay, we can go back there, and maybe before, let's say before, and maybe we can go to have an higher quality. I mean, because we have a little bit of gigabytes free. So let's go for 0.02, and we go back to the scaling we had before. We should use just a little bit less memory than before, so we'll have a lot of details, but we have a little bit of memory free for Windows and the user interface. Okay, so we will have no problem during the simulation. It's going really slow, so it means that we have really not so much memory to play, so it is better to do something to have more memory to play. You see that we have 7.8 gigabytes used, and we have just 8 gigabytes. A lot of detail, but it's too much for my GPU. So we can have a little bit less space for the bound to have a little bit of memory free. So let's do it. So you see we are going to scale it down a little bit and apply. We are using less voxel, so we have a little bit of memory free. You see we are going to 7.7, and maybe just this little bit of memory give us the possibility to be a little bit faster and responsive. So a lot of detail, and we are taking care about the simulation time that now is half than before, so that's good. You have always to remember to optimize the voxel size and the voxel bound. Okay, I think that the quality is really high. You see that we have a lot of details. We have the control over the density, the turbulence, we have the wispy look. So I think we've done something really nice. Actually, it's based for, it is perfect for a static cloud, and you can use the primitive you like. So everything it is attached as an emitter, you will be able to obtain a really nice effects like this one. We have to take care about some more complex setup for sure. So in the next part we are going to see how to export the VDB. We are going to see how to use a more complex shaping for the emitter, and then we'll need also to move to animated clouds. So we have to do something really interesting finally with Embergen. So you see that the quality in general is fast enough. You can try to export this one, or maybe we can export together real soon to see a rendering, maybe with some software, so you have everything. So guys, thanks for watching. It was a pleasure, and we'll talk really soon about